Okay, and here is the first part one of what we're going to do is we're going to try to analyze a DC circuit and then use the MultiSim to verify it. And this is an actual problem that we had in our class. And what we have is we have just a couple of resistors over here in series, a couple of resistors in series over here, and then a 120 volt battery. And we're trying to figure out basically what the power in each resistor is. And to do that, what we do is we combine the two resistors, so we have 20K over here, these two in series, and 12K over here, and these two in series. And now these two are in parallel, so what we have for the final circuit is 120, and this works out to be 7.5K. So the current total will be 16 milliamps. And then we can use the current divider rule to figure out that this I1 over here is going to be 6 milliamps, and I2 is going to be 10 milliamps going this way. And again, we're going out of the negative terminal into the positive terminal. And we get 6 and 10, and we add that up to 16, and that confirms what our I total is, so that checks. Now over here we're going to do the power is I squared R. So in resistor 1, which is up here, we've got 10 milliamps squared times 5200, so it's 0.52 watt. R2 is 0.68 watts. R3 is going to be in a leg with only 6 milliamps, so it's going to be 0.23 watts, and R4 is going to be 0.489 watts. Got a total of 1.919 watts total, and R2 dissipates the most. Now if we go to the MultiSim diagram or page, and we're going to assume that you looked at the video on how to set it up, we're going to run this, and this is R1, and again we see it's 520 milliwatts, what we saw before. R2 is going to be the biggest user, and that's 680 milliwatts. R3 is going to be 230 milliwatts, and R4 is going to be the 490 milliwatts. Now, what we do here is we're using watt meters. These are watt meters here. And so we're looking at voltage and current. And so we're measuring power is I squared R, or it's V times I. And now we say, well, are we sure we have the right current? In this leg over here, we see that it is the 10 milliamps. And this leg over here, it is the 6 milliamps. Now, an interesting thing when we were doing this, we just slapped down some resistors. And you'll see here, we're at 680 milliwatts, which is almost, well, it's about 2/3 of a watt. When we first did this thing, we put in the default resistors, and they're just 1/4 watt resistors, and would run for about a half second, and then the resistors would blow out, and we were kind of wondering why. It's because they didn't have the right ratings. So you have to make sure how much milliamps you're putting in, and to make sure you have the right rating. And also when you put these devices in, you have to be very particular. Remember, current goes out the bottom and goes into the top, so we want to have the right conventions. You know, this negative will be to this, and this positive eventually ends up here. And same thing over here. When we're running it, the current wants to go into these negative leads. So that's the first demonstration with MultiSim, and we'll go on to another demonstration for the DC circuits.